This is a resource to help students discover universal notions of transformations of functions and relations. It is dedicated to Zalman Yusiskin, who is a visionary and pioneer in mathematics education, and especially transformations. This resource, among other things, is trying to answer the question, why is it that when you replace x with x minus 3, that the graph moves 3 to the right? It starts with the idea of the general form of an ellipse, where you subtract for translations and divide for scale changes. It expands this to all functions. Coming from what's here called the home page, there are 5 parts to this resource. First, students can learn 5 important functions. This is particularly helpful to get everybody to a level playing field as far as knowing these 5 functions are concerned. If you click here, you'll come to the 5 functions, these here. As you click on each one, it will give you information about each one of these functions. Students can return here at any time to learn about the functions, that whether they go through the origin or not, some table of values, concavity, and so forth. Once students have learned some important characteristics about 5 functions, they can then go through the parts 2, 3, 4, and 5 of this resource. Before they do that, they should click on this answer sheet here, which will bring up a PDF, and they can use this PDF. They should print it out and write out the answers. In my opinion, it's quite important that they write out the answers. So let's take a look at translations. Here's the first problem. Note it's one variable on the number line. And the question is, what is the effect of replacing x with x minus 3? Hopefully students could see clearly that the answer here is, of course, 5. The answer here is 8. But when they slide down to the bottom, it's important that they think of the graph moves 3 units to the right. Note you can go back to the home page from any problem, and you can also click on the back button to go to a previous problem. So going to the next problem. Now, we also do one variable, but an inequality. The graph moves 3 to the right when we replace x with x minus 3. And then here we can actually see that h is the horizontal translation, and when we use the slider and change h from 0 to 3, the graph actually moves 3 to the right. Going to the next problem. Now, replacing x with x plus 1, moving the graph to the left. Also moving the graph to the left in the next problem, an inequality. Now we're going to do one variable, but on the coordinate plane. But still, when we replace x with x minus 3, it will move it 3 to the right. An inequality, one variable inequality on the coordinate plane. Here we do it one variable, but the y variable, it will move it up 3. Here it will move it also up 3. And hopefully when students get to this point, they'll say, when we go to 2 variables on the coordinate plane, they will simply say it will move it 3 to the right. If they don't see that, they could, it says down here, if you're finding this problem challenging, you could go back to problem 1, because in problem 1, it says, what is the effect of replacing x with x minus 3? It moves the graph 3 to the right. The rest of the problems in the translation sections vary horizontal and vertical translations, left, right, up, down, and also which function. For instance, a translation, a horizontal translation. Here's a vertical translation. In order for students to discover that it's a universal notion of transformations, they don't need to know what this graph looks like. They simply need to predict what happens when we replace y with y plus 3. And near the end, students will need to know how to predict what's going to happen when x is replaced with x minus something and y is replaced with y minus something. There are 20 problems in translations. When they've completed translations, they should go to the home page. Now students should continue on to scale changes. The approach taken here is to start with a circle. Note, students do not need to know anything about equations of circles in order to understand scale changes. They simply drag this equation over and they'll see that it's a circle. And the question is, what is the effect of replacing x with x divided by 3? The graph is a scale change by a factor of 3 in the x direction, which is a stretch. In general, you can see this stretch by changing b from 1 to 5 and see it being stretched in the x direction. Again, here is a function that they may or may not know anything about, but the question is, what is the effect of replacing y with y divided by 3? It's a scale change, a factor 3 in the y direction, a stretch. When students get to this problem, they might find it slightly more challenging. So there are these 2 points, reference points, that they can look at, and hopefully then they can see that instead of being 1 away from the y-axis, this point now is mapped over to here 3 times as far away from the y-axis. If they find this problem challenging, they can go back to problem number 1, which asks the same thing. What is the effect of replacing x with x divided by 3? And these problems are done then, of course, with a vertical scale change as well. And again, these points can help students understand why these transformations are happening. The next section deals with combining translations and scale changes. At first, again, taking a circle, whether they know that equation or not, and replace y with y minus 1, x with x minus 3, moving it, and then applying a vertical scale change. Most of the problems in this section are one in which they need to write the equation of the graph, and then they can move the graph to reveal the answer. In this case, there are 2 possible answers. When they're finished, they can come back to the home screen, and there is one last section, reflections. Reflections then ask, for instance, calling reflections a special case of scale changes, what happens when you replace x with x divided by -1, and then you can see by moving the slider from 1 to -1, making b -1, you can see the reflection over the y-axis. That completes the 5 sections, and students will probably need to repeat parts of this resource in order to attain mastery. Please click here to send feedback to me. Thank you very much.